Problem 5 gives us a table that provides information about the cost of eggs. We see the first column, the X column, is talking about the number of eggs, and then the second column, the Y column, tells us about the total cost in dollars for each of those eggs. Part A asks us to write an equation that could be used to determine the cost in dollars for any number of eggs, and we're going to use the data in the table to help us figure out what that equation might be. The table was copied onto the whiteboard here. We see the data. And I'd also point out at this point we should be familiar with y equals kx, or now what we're starting to call y equals mx, where we can write equations for proportional relationships, and we'll talk about why this table is a proportional relationship. And they always take the form y equals m times x, where m is your slope, slope is really your unit rate of change in the form y over x. So again, we're going to be looking for y change over x change, our rate of change, and that can help us quickly understand a lot and write an equation. I see that when it's 80 cents at 80 cents of cost, it costs at 80 cents for 4 eggs. That means I was paying 20 cents. If I do that division or simplify, I was paying 20 cents for every 1 egg. 20 cents times 4 would get us to the 80 cents. If we also did $2.40 for 12 eggs, 24 divided by 12 is 2. So that helps me know this is also 20 cents for every 1 egg. And what we'd see, this ratio continues. We double the number of eggs, the cost doubles from 240 to 480. And then again, the eggs double, the cost doubles. This is a proportional relationship where y over x keeps leading us to the same ratio of 20 cents per 1 egg. Once we know that slope, it's just a matter of plugging that into the equation, so that at that point we know y, the cost, will always be equal to 20 cents times x, which is going to be our number of eggs. So once we know the eggs, multiply that by the 20 cents per egg, and that equals your total cost. So once we have our equation in there, y equals 20 cents multiplied with the number of eggs, or multiplied with x, then they tell us a case of eggs contains 360 eggs. How much would that case cost? So we could take our equation, y equals 20 cents multiplied with x, and we're going to go ahead and full screen and pull this 360 eggs into our equation. So x is going to get replaced by 360. So I'm replacing x with 360, and that needs to multiply with the unit rate or the slope of 20 cents per egg. 2 times 36 is 72. And it turns out if we use a calculator, you understand decimals as well. 360 times 20 cents is going to give you a total cost of $72. So again, we can use this equation, substitute in the number of eggs for x, and the multiplication tells us the cost of the eggs has to equal $72. For part C, you're told that a local restaurant purchases $1,008 worth of eggs, and then the question is, how many cases did they purchase? One thing you could do is use the equation, and that equation, if we substitute it in for y, $1,008, we'll go ahead and put $1,008 in for y. One option is to solve that equation. That could tell you the total number of eggs once you divide by 20 cents on both sides. But then you would still have to convert those number of eggs, because x again is telling us, the number of eggs, to cases, because this problem asks us about cases. How many cases did they purchase? We see here, that's a really important part. How many cases? And we already know each case costs $72. So I'm just going to take the $1,008 and divide it by the $72 per case that we need, and that'll tell me how many cases we actually need. So 1,008 divided by 72 equals 14. So it turns out 14 cases of eggs equals $1,008.